This week we are introduced to multiple regression analysis, and in the chapter, the example that's used quite a bit is the used Camry example. So we are using the data here that's on your screen, and we have a sample of 20 different Camrys, and we have price as our Y or dependent variable, and we have two independent variables, X1 being for mileage and X2 for age. Now, in later sections, we work with the seller age as another independent variable, but for this particular example, for this video, we're going to essentially just ignore this variable for now. So what I want to do is recap just very quickly how we can run a regression with the data analysis toolpack in Excel, and then get to a later part of the section where we start talking about intervals, and more specifically confidence interval and prediction intervals. So in the chapter, there's reference to PHStat, and that is a application that we used previously in the course, an Excel file download basically. And so if you see the reference to PHStat, really what you want to be thinking of for our current course is XLStat. So we use XLStat in the same way that the book references PHStat. So because there are those references, I want to just show you how to get the same information for this Camry example as the PHStat example. We can essentially get the same thing with XLStat as well. So first off, we'll just do a real quick regression with the data analysis tool. And so here again, our dependent variable is price, and our independent variables in this case is just mileage and age. Those are adjoining cells there, columns. And we're going to work with a kind of a standard 95% confidence interval. And we can put our output just below our data. All right, and this is what we come back with, same information that you'll see in the textbook. So we have our coefficients here. I'll start highlighting a couple things for you. And we have our F-stat, we have our p-value, we have the specifics for the independent variables such as the t-statistic and p-values to test their significance, and we have a lower and upper range as well for each variable. Just recall that the lower and upper boundaries for the independent variables, these are referring to essentially confidence intervals that are used to estimate the population slopes. So we're using these lower and upper bounds as estimates of what the population slope for these variables would be in each case. So that's how we would solve this quickly with the data analysis toolpack. And now again, when we want to look at confidence and prediction intervals for the model, we'll need to do something a little bit more advanced. And in this case, we'll use XLStat. And here we can get the same information through our modeling linear regression application. But one thing I want to make note of first is that we are going to make a prediction. So in the textbook, it asks us to come up with a prediction interval at the 95% confidence level for a Camry with 76,320 miles and having an age of 6 years. So what we want to do is put this into our spreadsheet now, because we'll need to reference it for our XLStat regression. And so just kind of as a best practice, what I like to do is just put it down here so it lines up with the specific columns. So again, what we're asked to do is to make a prediction on what the asking price of a Camry should be if it has 76,320 miles and if it is 6 years old. Okay, and this is something, of course, that we could solve pretty easily with information that we already have by just creating the linear regression equation. So we have the coefficients here already for us, and we can solve for what our asking price should be just by solving the equation. So just as an example, we would take the y-intercept and we would add to that the coefficient for the mileage times the amount of mileage, and then add to that the coefficient for age, and multiply that times the age that we're interested in, 6 years. So with that, we get a price back of, or asking price of $11,476.90. We'll just format that. And because we're using Excel, we're using this application, it's going to be more specific with the number of decimals that it carries out to, the calculations. So in the text, you might see it rounded more to around 11,480. Again, just based off of rounding error. So we've got that predicted value there, but in order to come up again with confidence intervals along with this predicted value, we will use XLStat. So if we go to the linear regression tool, then our dependent variable is price. Independent variables are mileage and age. And now we have output going to a separate sheet. We have the variable labels box enabled or checked. And output is just really going to be the ANOVA table at this point. I don't believe I have any charts selected, nothing there. And so if we go to the prediction menu, this is where we'll input the specific variables that we want for mileage and age. So once again, here we are not able to just enter figures. I can't just enter 6 or 76,320. We need to use a cell reference, so that's why we input this first into the spreadsheet before even running the XLStat regression. So I'm going to go ahead and just highlight those now. And with that, we should be good to run the regression. These are the categories and that we want to check are mileage and age. Okay, again, those are the independent variables. All right, let's see what we come back with here. So we have some familiar information here with the coefficients. And F, you see the F value, F-stat, and P value for the model. That's just what we had here through the data analysis toolpack. And here are the predictions for our specific observations. So here is the predicted price. So that's what we calculated before, just kind of with a manual formula. So that's just using the linear regression equation, which XLStat kind of conveniently lists for you. And so we have our predicted price here, and then we have our lower and upper bounds for the confidence interval as well as prediction intervals. Widen this goes up a little bit. So here are the lower bounds and lower bound and upper bound for the confidence interval, which again is based on the an average. So that this what we're saying here is that this is the average asking price of a 6-year-old car with 76,320 miles and it being 6 years old. So this is the average asking price that we would expect the interval to be included in. And for the prediction interval, we have that listed separate here under the observation. And of course, you see this is a wider interval because it needs to be more precise, given that this is based on a specific 6-year-old Camry with 76,320 miles. So this is our prediction interval. So that's how we can use XLStat to run a multiple regression and make a prediction based off of a certain scenario, and then take it another step further and calculate the population confidence interval and prediction interval for that scenario. And again, this is used in place of pH-stat, which you may see a couple of times in the textbook. And we can also take a look at the specific independent variables and just note that the p-values for mileage and age are statistically significant if we were utilizing an alpha of 0.05, so a 95% confidence, what we ran in this scenario. So both of these p-values are less than 0.05, so these are statistically significant. And applying that to the model, overall model, we have a pretty good looking F statistic, and if we just look at the p-value, there's no critical value here. We need to calculate that separately to compare it to the F-stat, but we can just use the p-value approach here as well and note that that's well under even 1%. So this also proves to be a statistically significant model